Why do we want to talk about social media data and AI? A quote from Gemini: social media data offers a rich treasure trove for AI research. Public posts and interactions provide vast amounts of text and image data, allowing researchers to train models in tasks like sentiment analysis, understanding cultural trends, or developing chatbots that mimic natural conversation. The constant stream of data fuels the development of more nuanced and powerful AI applications. What are our data sources? When we put data on social media in the form of our profile information, our posts, our responses to posts, and so on, that data can be pulled to perform analytics on things like sentiment, trends, or for targeted advertising. Data analysis looks at a variety of data depending on the task. For instance, it may consider posts, keywords, hashtags, mentions, likes, shares, location of posts, and demographics on the author when available. Analysts may also do sentiment analysis and look at the sentiment of a post. Was it a happy post, sad post, angry post, and so on. This data can be combined in different ways to perform aggregate values such as counts, averages, or trends to do different types of analytics. The analysis can support applications like scientific research, market research, brand monitoring, social listening, public opinion analysis, marketing and advertising, or risk assessment. There are also data brokers, which take data from various sources, including social network data and additional public records, to combine or join that data to provide more complex data points. They then resell the packaged data to aggregators, advertisers, and unfortunately sometimes to bad actors who use the data for nefarious purposes. When you factor in financial company data, and you can imagine your credit information and other financial data being combined with your social posts, which may include your interests, relationships, or even location information. And then when we add insurance companies, they may add on data related to your health, your vehicles, and your home. Human resource and recruitment companies can add on work history and education data. And of course, background check companies might add on criminal record data. So all of this data can be pulled together by data brokers and then repurposed and repackaged and sold to different companies for different purposes. You can already imagine that in most cases this could be bad for users, right? While we might not want that kind of merged data sharing, looking at the aggregate de-identified data points or features, data that is not attributable directly to specific individuals, can be useful for scientific and market research. We can ask questions like, what are popular hashtags going around recently? What do people like currently? What do people dislike? Allowing companies to get a general feel for the space out there can help drive business and product decisions. You can see where this might be good and provide a social benefit. If it's trending that everyone hates the new label on your candy bar, you can change the label, improving your brand, and leaving the general population to find the next thing to complain about. Unfortunately, the same data can also be used to harm the user community. For instance, malicious actors can exploit hashtag aggregation to spread misinformation and propaganda by manipulating trending topics and filtering out opposing viewpoints. Of course, negative scenarios become even darker when you consider the data brokers pulling deeper personal data from a variety of sources and attaching that to your social media data. This can lead to further opportunities to do harm. So these are things to keep in mind as we look at ways textual data is processed in machine learning and natural language processing. We want to focus on the positive applications, but also be aware of negative consequences. In fact, knowledge of how data can be misused is critical to combating that misuse. So let's look at some techniques that can be applied to the social data set. Techniques for pattern matching are commonly used, where we aim to find how new data fits known patterns, or find patterns of similarities across a data set. Let's look at a few techniques at a high level. One technique is a support vector machine, which can be used for either classification or regression type problems. For instance, if you are given an input, a support vector can predict its class in the case of classification, or predict a continuous valued output in the case of regression. You can imagine applying this to sentiment analysis, for example, and labeling a social media post as positive, negative, neutral, or some level in between. Artificial neural networks are commonly used. These take inputs and perform calculations in one or more hidden layers that combine the inputs in different ways, such as taking the weighted sum of the inputs and applying some activation function. Each layer's outputs can become inputs to another hidden layer until ultimately a final output is generated. These weights associated with the connections between artificial neurons, represented by the circles here, determine the overall behavior of the network. Neural networks can be trained on data with known inputs and outputs, where weights are typically adjusted during the training process using an optimization algorithm like backpropagation. The number of hidden layers and the number of neurons within each layer influence the network's capacity to learn complex relationships. Another technique, conditional random field, defines a set of statistical models for calculating the probability of an output given an input. This example expression is based on an undirected graph model, which combines a transition feature function along with a state feature function and some weights. We sometimes consider only Boolean inputs, say in the case of sentiment analysis, if we classified a sentiment as simply negative or positive. Fuzzy logic provides a generalization of Boolean logic, where, for example, a temperature is not just hot or cold, but instead falls somewhere on a temperature scale of real values. So imagine we can assign any number of categories and form classifications based on a range of values. These types of techniques permit a finer-tuned output. Each of these methods, along with others, can be applied to different types of social media data. Of course, these are just a few techniques, and there are many more that exist and are continuously emerging and evolving as we grow the capabilities of AI in general. This has been a brief overview of social media data sources, applications, and analysis techniques. Of course, there is much more to explore.